So this is lesson 33, solving systems of equations by elimination. So far we talked about functions, and we talked about how we put things into functions and they pop out numbers, okay, and that we could use a graph to show how they pop out, okay. Sometimes though we want two of the, you want to take care of that? Just get it in, thank you. So sometimes we have two machines where we have different numbers coming out, and we want to find out which numbers will pop out the same answer, or which number will pop out the same answer. Okay, because you might have two different, like at home you have two different devices. You have your sink and your dishwasher, okay? You put dirty dishes in both, and one of them, the machine runs and you get a clean dish, and then the other one you have to put the dish in and you have to do a little work, and then you get a clean dish, right? Don't you get the same clean dish, but you just get them differently? You following me so far? So, same with math, we're looking at the same concept, okay? And what we're doing is we're trying to find where the answer is. Remember at the beginning of the year when we looked at these are just steps, but I'll come right back. But remember at the beginning of the year we had graphs look like this, and I said, what's the solution? This was like the first week of school. What's the solution here? It's where the lines cross, okay? So right now we know how to graph a line, and let's say these are two different functions. We're asking ourselves what input will produce the same output, okay, for both of them. That's where do the lines cross? That's what we're trying to figure out today. Okay? Does that make sense? So this is the beginning of the year. So we're not going to graph today, so how do we do it without graphing? Well, we're going to do this thing called elimination. We're trying to find what input will produce the same output on two different functions. Does that make sense? And we use this in real life. A lot of people do. They might have two different ways to find the same solution. Like a business might have a break-even point, and so they have two different functions. You have your line for production, and then they have a line for demand, and they're trying to find, okay, at what point do we break even? At what point are we starting to make profit? Okay, and that's really important. Figure that out. Okay? Alright, so these are the steps. So we're going to use just equations. We're just going to use algebra. We're not going to graph today, but we will graph, okay, in the next few days. We're going to go back to looking at the equations themselves. And we're going to use this term called elimination. So elimination, what does that mean? It means to get rid of, okay? Eliminate, okay? So when we're trying to eliminate a bacteria in our bodies, our antibodies in our bloodstream, are trying to eliminate a virus or a bacteria that's making us sick, okay? Trying to get rid of it, okay? Or your body has other things that it eliminates daily, okay? Right? Or there might be a government that's trying to eliminate a bad leader or some person that is in the world that's hurting other people. Or the government might have, maybe there's a death penalty and they eliminate a serial killer or someone who's very bad for society, okay, so to get rid of. Alright, anyways, those are some examples of eliminate. So the goal today is to eliminate a letter, okay? We have two letters in the equation always, x's and y's. What are the two letters? Okay, so we're going to eliminate one or the other, okay? Here we go. Watch carefully. Numbers 1 and 2. Okay, number 1. First thing I'm going to do is ask myself, we have two different functions here. I want to figure out where do the lines cross. There's a point. The goal is to find an answer that has an x and a y. Do we know what the x and y is yet? No, we don't. But we could easily find this by doing elimination. So the first equation we could call equation 1. The second equation will be called equation 2. So the first thing you want to do is make sure everything's lined up. X's are lined up, Y's are lined up, and with the equal sign. Okay, so they're all lined up, right? Then I ask myself, what do I want to get rid of? Okay, in this case, I'm going to put parentheses always around the second equation and ask myself, what do I want to get rid of? By adding or subtracting. If I add here the x's, then I wouldn't be able to get rid of the x's. If I subtract the x's, I still wouldn't be able to get rid of them because I'd still have negative 2x, okay? So then I move on to my y's. I'm thinking, okay, if I add my y's together, if I have positive y plus a negative y,
You can get rid of them.
exactly. She's so excited. Love the enthusiasm, right? So I want to use a plus sign when I'm getting rid of my y's. So I always put parentheses around the second equation. I's up here, i's up here, i's up here. So I'm going to get negative 3x plus negative x is going to be negative 4x. Then I have positive y plus negative y is going to be, they're going to eliminate. They're going to disappear because positive y plus the negative y is no y's. Or 0 y's. Eliminated, right? They are gotten rid of. Bring down the equal sign. We have 8 plus 8 is 16. Okay, now I eliminated the y's, so there aren't any more y's. So now we just have x's. So we're going to divide both sides by negative 4, solving for x. We got x is equal to negative 4. That means in my answer, this negative 4 will go in my answer here. So I could even write it here, negative 4. Now how do I find the y? Okay, now that I know the x.
You plug it in to one of the equations, and then you'll get the answer.
Okay, wow. Okay, you should teach the class today. That's great. So you take one of the equations, and I usually try to pick the easier one from the beginning. Which one is easier? I think equation 2 is easier because there isn't like a negative 3x. There's just negative x minus y is equal to 8. So I'm going to have negative x minus y is equal to 8. Instead of x, I'm going to put negative 4, so it's going to be negative 4 minus y is equal to 8. So this is like saying positive 4 minus y is equal to 8. Subtract 4 on both sides. Negative y equals 4. And then we're going to... y is equal to negative 4. That's good. I like it. So the point where these two lines cross is negative 4 and negative 4. That's the negative 4 is the ingredient that's going to pop out the same answer in both equations. Does that make sense? Okay? Raise your hand if you've seen this before. Okay. Definitely know one of you have seen it before. Isn't this fun? Do you like this one? Okay, it is fun. I like this one. It's like a puzzle. I like it because it's like a puzzle, because you're like trying to solve a puzzle. Okay, so let's do number 2 now. Eyes up here. I'll give some space here. Always start by naming the equations, and then I always put parentheses around the second equation, along with a bar, like a add, addition, subtraction bar. So, looking up here, I'm going to look at my x's first, and I'm going to ask myself, if I put a plus sign out here outside of my x's, negative 5x plus positive 5x, what will happen? Well, these will eliminate, we want that. So this plus sign is perfect. So we're going to keep this plus sign. So we think negative 5x plus 5x is going to be 0x. So these get eliminated. Okay, so these are done. Positive y plus negative 5y, okay, which is equal to 1 plus 15 is 16, okay? So divide both sides by negative 4 now that the x's are eliminated. So y is equal to negative 4. Okay, so in my answer now, we have an x and a y. We know that the y is negative 4. So that is the output. So how do I get the x? You just plug it back into whichever equation. So I always pick the easier one. Looks like equation 1 is easier. So we got negative 5x plus y is equal to 1. So instead of y, I'm going to put negative 4. So we got negative 5x. This is supposed to be an x. Plus a negative 4 is equal to 1. Positive and negative here is minus, so we got negative 5x minus 4 is equal to 1. Add 4 to both sides. We get negative 5x is equal to 5. Divide both sides by negative 5. And we get x is equal to negative 1. Oh, negative 1. So that means our answer, or our point that the lines cross, is negative 1, negative 4. Okay, that would be your answer. Does that make sense, everyone?
Yes.
Okay. So, some of you it isn't going to make sense, so that's every day we kind of try to make sense. You have to persevere and try to seek that understanding, okay? So, in order to make it better sense of it, let's have you talk with your neighbors. Let's have ones tell the twos, or at least the person who understands it better to share first about number 1, and then twos will talk about number 2. Ready, set, talk. Continuing number 3. Shh. Okay, so the first thing you want to do is write the problem out, so I'll give you a moment to write it out on your papers or on your iPads. Number 3. And next to each equation, I want you to name it. The first equation you should name equation 1, the second equation, equation 2. And then put parentheses around the second equation and put a bar underneath it. Oh, excuse me. I'll fix that. Darn it. To eliminate the x's or the y's. You can only use plus or minus. Which one do you want to get rid of, x's or y's? Which one? Everyone? Okay, y, okay? So we have to ask ourselves, let's put a plus sign in front, and let's just focus on the y's. Let's see if the plus sign is the one we want. Negative 3 plus positive 3y is... What's negative 3y plus positive 3y? 0y, right? Which means it eliminates. So we use the right operation. If it didn't work, you would use subtraction, okay? So now let's just work it out. We got negative 4x plus x is negative 3x, okay? You're working along with me, okay? The y's got eliminated. They went bye-bye. And then we got equal sign. Negative 5 plus negative 1 is? Negative 6, good, okay? Then we want to solve for x. Everyone's working on this. How do we solve for x now?
Divide by negative 3.
We divide by negative 3. So we get x is equal to? No. What's no? Positive 2. Okay? So that means in our answer we would write next to it would be 2 is our first part of our coordinate or ordered pair. Okay, how do we get now the y? How do we solve for y?
I want to plug in the 2.
Plug it in to which one? Equation 1 or 2?
Number 2.
Okay, that sounds good. Equation 2 looks easier than equation 1. So we take equation 2, and we're going to write it down. X plus 3y is equal to negative 1. And instead of x, we're going to substitute it with 2, okay? And we're solving for y now. Negative 1, sorry. Okay, so how do we solve for y now? What should we do? Subtract 2 first, good. So we got 3y is equal to negative 3, okay. How do we solve for y? Divide by 3 on both sides, so we get y is equal to?
Negative 1.
Negative 1, good. So then we put negative 1 all the way back into our ordered pair. Let me see your answers to make sure you did it correctly, like mine. I'm gonna okay, so number 4. Okay, number 4. First step, let's name each of these equations. So equation 1 and equation 2. Put parentheses around the second one always, and then put the bar underneath, okay? Ask yourself, which variable do you want to eliminate, x's or y's? With a plus or a minus sign. Okay, good. X's. Okay, so what happens if I put in a plus sign in front of this? What's x plus x? 2x. Does it eliminate?
No.
No. So do we want to use plus sign? No, let's try minus sign. X minus x is 0x. Okay, good. So does that eliminate them? Yes. Okay, so we're going to use that. Negative 3y minus positive 2y is? Negative 5y, right? 15 minus a negative 10 is? What's 15? Nope. Nope. When you subtract a negative, you're really adding, right? So what's 15 plus 10? 15 plus 10? 25, good. Divide both sides by negative 5. Y is equal to what, everyone? Y is Good, -5. Okay, so in your answer, your y will be...
What is that? Plus 5.
The 15 isn't negative.
That's 25.
I know. Well, let's. I think I went too fast for some of you. 15 minus a -10. When you subtract a negative, you're adding. What's 15 plus 10? 25. When you 15 minus a -10. When you subtract the -10, you're really adding, right? You following me? Yes?
Where'd the negative come from?
Because you have to, we use the negative sign to eliminate the x's. What happens if we use the positive here? You would have had 2x. Would that eliminate it? No. Did y'all get that?
Yeah.
You have to use the correct sign out here in order to eliminate it. Did you get it? You understand? 15 minus a -10 is positive 25. That's a good question, okay? So this gets tricky, right? Because you have to use the right sign on the outside. Alright, so x's and y's. Our answer for the y's is -5. Answers for the x, okay? Which equation do you want to put in for y? 1 or 2? And by the way, it really doesn't matter which one you use, okay? Bottom or top? I'll use the top one, okay? So, here we go. And again, it doesn't really matter, okay? Let's take a vote. Which one do you want to use? Raise your hand if you want 1. Raise your hand if you want 2. Okay, 2 wins. So I'll do 1 to prove to you that 1 still works. Okay, 1. So x minus 3y. Actually, why don't you do the 2's? Everyone has a 2, or who voted for 2, do 2's. Okay, I'm going to do 1. Make sure you copy it correctly and then substitute. Instead of y, use -5. So we got x minus 3 times -5 is equal to 15. -3 times 5 is positive 15, so x plus 15 is equal to 15. Subtract 15 on both sides. Oh. What did you get as x, everyone? X is equal to?
0.
0, right? So the point in which these two lines cross is 0, -5. And that would have worked for the other one as well. Okay, let me make sure yours looks like mine. Answers up.